vulnerabilities, how we determine if this vulnerability can or cannot be exploitable, and why this is so important. I think everybody who is here already know and understands the challenge that we have nowadays. In the previous presentations, in the keynote, everybody was discussing and talking about full-day vulnerabilities, vulnerabilities that are new, vulnerabilities that don't have a patch, but nobody really explained, oh, okay, how do we detect this kind of vulnerabilities, how the researchers are working, and what the companies are really doing with that kind of information. So I will try to talk about what is the fuzzers and misconceptions about fuzzers. I will try to explain how it works, how the software flaws works, how do we analyze the target internals. I will explain the implementation details and stuff, showing as much as I can, and everything in 60 minutes. So basically the objective, what I really want everybody to understand from this talk is every time you are opening a file, you are basically giving remote code execution in your machine. That's the main purpose of this talk. I really want everybody to understand that when you have a resume that you just received, and when you just double-click this resume, you are just executing a shell for the remote attacker. So how this shell will work or why it will work is the main purpose of this talk. What is important is the file formats nowadays are really complex. These softwares are really, really complex. So as you can see, I opened the resume, and the resume popped out to me as CMD. Okay? Why? Because Adobe Acrobat Reader has bugs. These bugs are being constantly exploited. If you are using Internet Explorer and you have the Adobe plugin, you are going to be exploited. If you don't have the Adobe plugin, you are going to be exploited as well, because you are parsing very complex piece of software. Every time you have a complex parser, you are going to have vulnerabilities. And we, as security researchers, are looking for these vulnerabilities. We are finding them. We are determining if it can be exploitable or not. And we are writing the effective exploits to prove the idea. Sometimes the bad guys are doing that faster than us. Unfortunately, they have much more money, much more research, much more time to do that. The motivation for the bad guys is much bigger than for the good guys. So they are usually faster than us, but we are also doing that. That's important, an important message. Another important message was something that I learned when I was discussing with a friend of mine. This friend of mine, he's a developer in a security company, so he develops security products. And I came to him really motivated to say, hey, I just found a bug in the product you just released. And he looked at me and, hey, why you are happy with that? And I said, oh, I don't know, it's my job. I am supposed to be happy when I succeed in my job, right? And I said, yes, come on. Every time you find a vulnerability, you are disappointing the guys who are writing the software, right? Because the guys spend a lot of time trying to create a good software, and we just, in a couple of minutes, couple of hours, sometimes couple of days, we just find a vulnerability, and the guy, oh, come on, he's disappointed. He will, have a lack of motivation. That's really funny, because if they patch the vulnerability, instead of take out the attacker motivation, they are giving even more motivation. Because as he said, hey, every time we patch or every time we have something new, you spend even more time looking for vulnerabilities. So it's a kind of not fair for the guys who are defending. Because they don't have the motivation that we have when there is something being really fixed. So that's a kind of interesting. That's why I like pretty much my job. So everybody knows that security nowadays comprises of bugged softwares being deployed, everybody trying to develop as fast as possible because you want to be the first one in market. Everybody wants to not expend a lot of money with really advanced developers, so as cheap as possible is better. And everybody wants, beautiful interfaces for the development so they can develop it really quickly. And, we know that. We know this is a mess, and that's why we are here. My idea is to show how we are going to audit these systems and how we are going to find the vulnerabilities and try to find it as fast as possible and as much as possible, keeping the quality. So basically, we all know that in the beginning, a worm to spread took like a long time. It took a long time when the vulnerability was released to have a really working exploit. And nowadays, everything is much faster. And why it's so fast? we now have like non-executable memory, we have address space layout randomization. It was supposed to be even more difficult to create an exploit. But in the practice, what we see is like the exploits are being developed even faster than they were in the past. Why is that? Because the attackers are professionals. They have the right tools to analyze the vulnerabilities. And this kind of tools to analyze the exploitability of some kind of vulnerability is the kind of tools that the security community needs to develop and needs to start to share. So just a question that I like to ask: how many times do you guys think a vulnerability remains like hidden from the public knowledge since it was found by somebody? An all day. So let's suppose I'm auditing a piece of software, I found a vulnerability, and I don't tell anybody. I just keep counting to wait for how long this vulnerability are going to take until somebody else finds it and publish it. How long do you guys think? An all day remains all day. How long? Give me a number, any number. 10 days? More than 10 days? 1 year? Good. 1 month? 1 year? So what the number says is the average, it's almost 1 year. Okay? The shortest time is at least 3 months. So what we are saying is, since somebody finds the vulnerability, it takes a lot of time until somebody else finds it. So the guy has plenty of time to negotiate the vulnerability and to get the best bet for it. That's pretty interesting. That's pretty cool to know. So it's worth to invest in that, because you are doing a research that even if you find something and you don't do anything with the information you have because you don't know how to get money out of this information, it's going to take like at least 1 year for you to figure out, hey, now I know how to make money out of vulnerabilities. And in fact, we have like nice companies, not bad companies, at least we hope, that are really investing a lot of money in finding vulnerabilities because they have a whole business model out of that. So what is a fuzzer? Basically, the idea of fuzzer is that's a really busy word. Everybody is talking about fuzzing nowadays. Everybody knows that it's pretty hard to audit the code, to just look into the assembly instructions. So everybody says, hey, let's fuzz, let's fuzz, let's fuzz. But what is really fuzz a software? What is the idea, and what is wrong with what everybody is doing? Why, for example, Microsoft fuzzers are not finding all the vulnerabilities? Since Microsoft also has fuzzers, right? Microsoft has a lot of good researchers. They are deploying a lot of machines, and they are fuzzing as well. So why Microsoft is finding some stuff, other researchers are finding some other stuff? Why it is so difficult to fuzz a software? Because the software is a really, really complex piece, of something. As everybody said already, the vulnerability is just, using this complex machine in different ways than it was supposed to be used. So it's pretty hard. But it's also important to note that the fuzzing definition itself is a kind of lacking, or is a kind of weak. So there is some, misdefinitions on that. So I got the fuzzer definition from Wikipedia. And if you look into the definition, the idea of fuzzing is if the program fails, we detected some problem. But what if the program don't fail at all? Or what if the program failed because of something you did in the past, but this just appeared like 2 hours later? How do you know what we did that really managed to crash the application? So fuzzing is not as simple as everybody thinks it is. Also, we need to remember that the file formats are pretty complex nowadays. So when we talk about like Adobe, which is just a front end for a remote attacker, it's not just because Adobe wanted to be a front end for a remote attacker. They don't want this. I'm sure they don't. But why is this happening? Because they have like videos inserted in PDF documents. They have like a whole file system being managed by PDF. They have encryption. They have encoding. They have multiple layers of encoding. Everything supported by definition by the format. So the file formats are pretty complex. And because the big companies really like complex stuff, Google is proposing a HTTP version just using compression. So do you imagine the life of the IPS guys creating IPS to protect the whole network when everything was compressed? It's going to be really fun. I really hope Google managed to have everybody using it. Okay? So the truth is, the software is complex. The computer power is growing, the network power is growing. The only ones who don't take advantage of that are the IPS vendors, because the endpoints are growing much faster than the IPS machine. So it's almost impossible, the challenge, to really inspect these complex file formats. Okay, so we know the file format is complex. I hope everybody agrees with me. If you don't, try to read one of the specifications, and if you understand from the first read, either you are a genius or I'm wrong, but I think you're probably going to be a genius if you understand in the first read. But there is other mistakes in the way people are fuzzing. So just because the name fuzz means there is no real order on that, don't mean that you need to do a catch in the dev random and pipe it to your application. You need to fuzz with intelligence. You need to understand what the application is doing. And you need to understand that just code coverage means nothing. Maybe you are covering 90% of your code, but this 10% that you are leaving not covered is where the vulnerabilities are. So what you want is to cover the vulnerabilities. You don't care if you are covering the whole software or just where there is vulnerability in the software. So that's also important. And, well, most of the fuzzing solutions are trying to have some information about how the target is behaving, but usually it's like after the crash. So like, for example, in Cousin Inc., we developed like a fuzzer for Word. So they have like 200,000 crashes in Word. From these 200,000, how much of this are real vulnerabilities? What can be really exploitable or not? It's pretty hard to determine. And this fuzzer is just, dumping the crash file and the not exploitable view of the exploitability of this vulnerability. For those who don't know what is the not exploitable, I will boot the other virtual machine and then I will explain what is the not exploitable. But basically, not exploitable is an extension for the Windows debugger that Microsoft provides that will help you to analyze if a vulnerability can or cannot be exploitable. And, they try to do some kind of taint analysis. I'm not saying it's bad. I'm just saying that at least it is open source, so nobody can really complain when a software is open source because you can, in the worst case, improve it. But what it's really doing is like most of the real vulnerability, it says unknown or not exploitable. Some of the pretty obvious, they will say it's exploitable, of course, because it's pretty obvious. But a lot of vulnerability, it says it's probably exploitable or not. So in the end, you cannot really count on the information a tool like this is really outputting. So it's pretty hard and it's pretty challenging to really analyze a vulnerability. So I will let the machine booting while I keep talking. So what is the actual state? So everybody is trying to, in some way, create new ways to fuzz, smarter ways to fuzz. So basically, when you are fuzzing something, you need to understand that there is a protocol in respect of this application. This protocol may be like a network protocol, so you need to send specific packets in specific orders to really test the application, to at least go into the parsers of the application. But you also have like file formats or other stuff that you don't have access to the network. So not always when you have a crash, you have a vulnerability. If it's a network software, if you have a crash, at least you have a denial of service, right? It's network software. But when you were talking about, like, for example, Adobe Reader, Word, not because you have a crash, it's a vulnerability. Maybe this crash is just a crash. It means nothing. Actually, the recover feature of Office works pretty well. So even if it closes all the instances of Office, the guy is not going to lose the documents anyway. So you cannot say it's a vulnerability. It's just a crash. So how we differentiate that? It's something that is important. And, some guys created the idea of, mutate some non-good data. So you get some data that are used to be good, and you start to change and play with the format, and it starts to pass this data to the application. If it's a network application, you get some package captures, you change it, and you send to the application. If it's, for example, Word, you get a really complex document with a lot of links and formats. You change what it's doing, for example, creating malformed object, and then you open Word and try to see how it works. Of course, some softwares are easier to fuzz than others. Like a network server, it's supposed to handle a lot of connections. So it's the perfect victim for fuzzing, right? That's why everybody talks about fuzzing network applications, because it's pretty easy. And every crash is a vulnerability. But what about Word? Word takes, 10 seconds to start. in a really good machine. I'm really optimistic guy, but Word takes a lot of time. So how do you generate an open Word, generate another one, and open another one? It's pretty time consuming for the fuzzing vision. So one of the ideas that I created is instead of generate different entries, I'm trying to change the way the target is really behaving. So for example, if I know some kind of information, I have control over the information, I will change the way the target behaves when it receives the original information. So what is the idea? Let me get this application, for example. It's a disassembler for one application, and we are just comparing the parameters for the application, and we are jumping if equal, okay? If I know I control the parameters, I control the result of this operation, and I'm fuzzing, and I know this jump. If I really avoid the jump, I can get into vulnerability. I know I can do that. I don't need to generate a new input for the application, send the input to the application again, and see how the application is going to behave, because I already know I can do that. So how it will work? Let's get this application, for example. It's an a.out, so the application is just testing the arguments, and it's printing a help message if you don't pass the right argument, okay? So what happens if I run this application, and exactly in the point where is this jump, I just tell to the application, hey, I want you to jump, no matter what is the value. I know I control the value anyway. So I can do that, because I'm doing live analysis anyway. I am analyzing the target, I'm looking how the target is behaving. So instead of changing the guy who is creating the packages, I'm doing the changing the target itself, because I know in the end, I really control that. Why this small change is important? Because basically, fuzzing and test a software is a problem that you cannot solve with a deterministic algorithm, right? But if we do this kind of stuff and we can change that on the target itself, we can create a cluster of machines, and then we have an undeterministic Turing machine to solve an undeterministic problem. So this means the problem can be solved. So this means that we can really solve the problem of software testing just doing that. So in this case, as you can see, the application, even not receiving the arguments, the application is going to say, hey, welcome. I just bypassed the application itself, the way the application behaves internally. So cool. Going back to the not exploitable. So here we have like a word vulnerability, okay? And here we have like the not exploitable output of this vulnerability. I really don't mind if everybody gets the addresses and then try to locate what is the vulnerability, because this one is a pretty complex one in the end. So if you find it, good luck. But well, basically what the not exploitable is saying is the exploitability classification is unknown. Why? Because the software is stopped in a int 3. Okay? The software is stopped in a debugger interrupt. So what the heck the software is stopping in a debugging interrupt? According to not exploitable, really cool. It's an indication that maybe an attacker is testing the target. But anyway, breaking points are not supposed to appear in production software, right? But what is this debugging interrupt that appears in Windows? Really cool. In the Service Pack 3 of Windows XP, they inserted unlinking protection in the heap. And this unlinking protection, when it's triggered, it generates a breaking point. So they say it's not recommended, it's not supposed to appear, but they inserted that on purpose. And in this case, it's clearly showing there is a heap consumption, heap problem, okay? So we are overwriting structures on the heap. If you look into the stack of this process, you are going to see it's related to, like always, HTML parsing. In this case, HTML parsing inside Word itself. Okay? So it's a kind of interesting, because the software is so big that even the guys who are doing actual research in Microsoft are recommending something. The guys who are also doing research there and are trying to create protection are doing something else. And the tools are not reflecting, because they can't be as fast as the software is growing. It's a challenge for them. And it's a challenge for everybody else really trying to protect the companies and finding the vulnerabilities. So if we use this static analysis to really feedback the fuzzer and achieve this coverage, but the coverage of real pieces that we really want to cover, not the whole code. We don't want to cover the whole code. We just want to know where is the bugs. I don't care if there is a crash. Sorry, I really don't. It's not my problem, right? If the process is, using more memory than it is supposed to, I really don't care. But if I can force that situation in a remote server that will lead to a denial of service, then it's my problem. So then I have interest in C. So the idea is, like, all the approaches are using the fuzzer as changing. My approach is using the target being changed, okay, when I really know I control the information. So just to explain a little bit about memory corruptions, how it works, why it's so important. Well, the memory corruption vulnerabilities are going down. It's decreasing, okay? But it's still the vulnerability that we see in the worms. It's still the vulnerability that somebody used it on Google, right? Everybody read the news. Wow, Internet Explorer vulnerability. Let's on Google and let's on other companies in the US or whatever, because they still, well, why Google was using Internet Explorer? That's interesting. Huh? Well, yes, because they wanted a front end for command execution. That's what they were looking for. Okay, so basically, we know that the low-level vulnerabilities are decreasing, but still, they are the most important ones. They are still really important because it will give you access to the internal network, which we know it's usually messy. It will give you much more priority when you get into, or for example, if you use like a web vulnerability to get access into a server, you want to have administrator access, so you need a low-level vulnerability to really increase your power inside the machine. So when we trigger a vulnerability, usually people say, hey, the program will crash, but that's not true. As I said, sometimes you have a problem, you overwrite a pointer, for example, in the memory, so it means there was a memory corruption, but this pointer is not going to be used, at least soon, or never in the program, unless you have another condition. So we need some way to really understand what we are overwriting and what we are not. So the classical, draw about memory corruption, it's so easy, huh? It's just, okay, we overwrite the stack, we overwrite the return address, perfect. There is nothing else in the memory of the application, right? The application don't do anything useful. Usually the applications are there just to be exploitable, right? No, we know it's not true. So I think it's really good if the security guys stop to simplify stuff. Okay? The vulnerabilities are not so simple to exploit. There is much more stuff there. Okay? The classical stack overflows does not exist anymore. Okay? Forget it. Unless it's Adobe. Yeah. Well. But well, okay, so what we have? Basically, when we are fuzzing an application, we have an application that is in normal behavior. Okay? Well, when we have any kind of corruption, I don't know which kind of corruption, but let's suppose we have a kind of corruption, like a memory corruption. The application can change to a critical state, or it can, like crash instantly. If it crashes, it's very easy. You just know what you just modified in the package, so you know why it crashed. It's pretty easy to analyze. Usually this one is the, best one that you want to find, right? Because quickly you can at least know what crashed, and then you can further do the analysis and see if you can exploit. The biggest problem is, like, sometimes the normal behavioring will pass to be a behavioring, okay? Not really normal, but the software is working, it didn't crash. How do we spot it? And well, if we have like other instruction really using this data that you just overwrote with random data or whatever, then you can have a crash. And then when you look into the crash, hey, why am I crashing? I didn't do anything that's supposed to crash the program. But actually you did. You just don't keep the track, right? Because it's an explosion of combinations. So the fuzzer cannot keep the tracking of everything it's doing, okay? What you can do is like try to reproduce all the steps again. So you start to lose the productivity of the fuzzer, right? Because if all the time you have a crash, you need to launch all the sessions again so you can figure out which session generated the initial corruption, you are going to have a problem. So, okay. Also, we know that maybe we have like a kind of critical data corruption and we don't have like the control yet, so we are going to have an inconsistent execution. For example, the address pointer is going to redirect the code to execute something crazy in the memory, and the application didn't crash. The application is still running. You just overwrote the EIP, so you got the control, but you don't know, and your fuzzer don't have any way to know, right? Your fuzzer is just sending packages. So the application starts to execute something crazy, and then the application crashes later, and you have no way to know because you just didn't predict and you didn't got the control because your fuzzer is not an exploit that will do everything as you wish. Your fuzzer is just sending information. Of course, when you have the crash information and you do all the analysis, so you disassemble, you understand which registers you control, you understand which kind of information you control, what you can overwrite, what you can't, how the application is behaving when you are overwriting specific piece of information, then maybe you can have like the real compromise. So basically, the challenge of the fuzzer is remaining like, how I give you information that will really help you to create and work in exploit. And you may say, hey, why you want to work in exploit? Because when you are auditing a software like Word, you are going to find like 200,000 problems. And you really don't want to send 200,000 advisors to Microsoft because they are not going to patch anyway. So what you need is you really need to classify and see what can and what cannot be exploited. So what? Let's just say that if we have, for us to really control a code, to really exploit a vulnerability, we need to control some information that the vulnerability is using. So for example, if we really want to gain like as a command execution or whatever execution, arbitrary execution in a software, this software needs to use the data that we are sending to the application in somewhat to, for a branch, for a call, returning, using the information in the stack, but somewhat this information that we are sending to the software needs to be used. Otherwise, we don't have the control of information, okay? So when we want to determine the exploitability, we want to know what the software is actually doing with the information we are sending to the software. So to really know what's going on inside the software, we need a debugger, right? We cannot just guess. We need a debugger, and this debugger needs to give us this information. So I can safely say that any data that an attacker or somebody else interacting with the software is generating to the software, any data cannot be trusted. So we know that if I am inputting something to your software, and your software really likes this information and uses that as a return address, it's something wrong with the software. We know there is a problem, a security problem in this software. So the idea is like we need to keep track of the information we are sending to the software. So that's how tent analysis starts to play. So the idea of tent analysis, any kind of untrusted data, we are going to mark and we are going to track. And we are going to see how these data are changing the behavior of the software. So the fuzzer itself is important. It is because it needs to generate the information, it's blah, blah, blah. But what I am focusing here is which kind of information the debugger are going to provide to the fuzzer in order to really have a smart fuzzer, a fuzzer that you can say it's evolutionary, okay? Not just something that will generate new packets, okay? The idea is like we need to keep track of this data. We need to monitor the program execution and how this data is passing through the program. And of course, we need to check if this information is going to be used in something that are critical or is going to override something that the program really needs. So how do we do that? First of all, it's important to say there is other real-world applications for tent analysis. So this guy, Jin Shou, he explained that he did an analysis using a tent box machine. So he had like a box emulator. He modified the box emulator to keep track of the registers and monitor what is going on. And he used a tent analysis to determine how long critical information are remaining in the memory of softwares. So how long? For example, you type your password in Messenger. So Messenger authenticates yourself with the Messenger server. So how long the Messenger client are keeping your password in the memory? After the authentication, there is no why keep the password, right? So they did an analysis in the server, and they used the tent analysis to keep track of this information, and the discoveries were really cool. Most of the softwares, just keep the information. That's something that we will need to care as well, because if we can have a vulnerability, that we can force the vulnerability to become a format string vulnerability, because we control the format string being sent to some function. We can dump critical data from the memory, and we don't need code execution at all. So don't matter if there is code, non-code execution protection or not. It's really not important. If I can dump all the passwords from the memory itself, it's okay for me. Okay? Good. So how do we do that? Basically, we always need a kind of assembly emulator. And, well, Valgrind is one open source option. It's a good option. You have plenty of other options like bnav by the guys from Dynamics. You can use Box and just modify it. It's open source anyway. You can use Bastard, which is disassembler library that I am one of the guys who wrote it. It's pretty old. Don't use it. I don't use it, so I don't recommend you to use it. But yes, anyway, it's an emulator. What is the idea of this kind of emulators? Why we need to use this kind of emulators? Basically, we don't want to parse the whole assembly language. We want a simplified view of the assembly language. So if we have a bunch of instructions, and those instructions are doing exactly the same thing internally for the program, we want this to be simplified for us. And also, we want to easily port this assembly machine to other kind of situations. So for example, if you are exploiting a vulnerability in Intel x86, you want also to exploit the vulnerability in Intel 64, whatever. So this kind of emulators are always transforming the instructions to an intermediate language that you go to use to create the tent check. So how does it work? So basically you have the data from the fuzzer. The data from the fuzzer is being sent to the target application as normal. Let's suppose this target application, is copying this information from the network to a malloc buffer or whatever. And, we know this data. There is some data that we don't control. For example, let's suppose this malloc allocation is a fixed allocation. We don't control the value of the size of the allocation, but we still control the data inside the buffer itself. Okay, cool. So we know that we need to keep track of this untainted data, and because this information we control, so we propagate the tent. And if this information is being copied to another buffer, we need to check this buffer as well, because we start to control this buffer as well. So we need to propagate what we control and what we don't. So if at any point we have any kind of weird behavior in the application, I will show how we determine what is weird and what is not. We just send back the information to the fuzzer. For example, if there is an if condition that I know that this if condition is avoiding, for example, buffer overflow to happen because there's an if condition, I will patch the target to bypass this if condition if I know that the data that are using in this if condition, I have control over it. If I have control, I don't need to really test it. I know I control, I just modify the target to be sure the overflow is happening. If the overflow is really happening, I just send the information back to the fuzzer and say, hey, if you send this package with this modification, you are going to achieve a buffer overflow, for example. So this creates a lot of combination problems. I am not sure if you guys are, into this assembly study and how to solve this kind of machine analysis stuff, but the set solver is the first really, really real problem in the computer world. It was the first problem that the guys used to prove it's impossible to decide. So what is the idea? Let's get the simple case. I have A. A is a piece of information that I control. I'm copying A into a register, EAX. I know I control EAX. So EAX is now being tainted. If I copy EAX to B, B is a piece of information that I also control. So B is also tainted. Pretty simple. Now how do we solve this situation? I control D, but I don't control the contents of EBX. What if this D is being added to EBX? Do I control EBX or I don't? What do you guys think? This is a pretty simple example, right? I partially control EBX. But if then EBX is used in addition with ECX, which I also don't control, do I control ECX or not? And it starts to create an explosion. And if you just assume that, okay, you control EBX, what's going to happen is you are going to have a lot of false positives. So you don't want to say you can exploit something that you can't. So this is one of the biggest challenge, how to determine this kind of situations. And basically, I'm going to explain how it's working nowadays. So this dynamic analysis needs to keep track of the program state. That's a kind of obvious. I need to know what is where, which kind of data is where. If some data that I control is in the memory, I need to know that I control this area of memory, so I need to kind of mark it. So I need to monitor memory writes and check for violations. So let's suppose I am writing to the memory in a buffer. So this buffer was allocated, and the information that I control is writing past this buffer size. So I know I have an overflow. That's something pretty easy that I can define. But let's suppose this situation. You have A, which you know you have control, and you are ending this A with B, which you don't control. So if B is 0, you don't control B, right? It's clear or not? I control A. I'm using AND operation with B. I know that B is 0. It means that I don't control the result of this AND operation. So I remove the tent. What if B is 1? I control or I don't? If B is 1, I know that B is 1. A, I know is a value that I control. And there is an AND operation between A and B. Do I control the result of this operation? Sure I do. That's great. So I need dynamic analysis to do that, to know that. Because if I don't know that B is 0, I will never know if I control or not the result. I may guess and say, hey, I control, but I don't. So it's impossible, right? We want to know. And this same rule applies to any kind of Boolean operations. Okay, XOR, NOR, OR, okay? You always have something that you might control, you might not, but with dynamic analysis, you can see from where this information came, and then you can really determine what is the result of this operation. And as I said, I instrument the binary in runtime. So if there is going to be an if condition, I know that I control everything that is used for this condition to happen, to be true, for example. I know I control it, so I can determine if I will take or not the jump. I don't need the program to just run in the normal way and then change the package, send a new package, start the word again, and then try again. I don't need to do that. I can just patch it on the fly, as I showed. Cool. So how do I keep track of this information? Basically, there is like 4 different structures. One is the used memory. So everything that the program is using in the memory, it's what I call used memory. So if I know there is some var being copied in some place of the memory, this is as used memory. There's also the control memory. The control memory is the information that I care more, right? Because if I have control over the control memory, much probably I'm having control over the code itself. So the control memory is, for example, if there is a call, the return address is going to be saved in the memory, in the stack. So this area, this location of the stack, I mark as a control memory. Because I know if I have an overwrite of this saved raster with a data that I control, I know I am having control over the execution of the code. That's cool. So the same for saved rasters, return addresses. So for example, saved rasters. If I know there is like, for example, in the function in the start of the function is saving some rasters. And then in the end, it's getting back the value to the original raster and returning to the Kali. Okay? If I have an overwrite over this memory area where the rasters were saved, I know that I control, for example, EBX in the Kali. Because when the function returns, this address that I overwrote now are being used by the Kali. So I know that I have control over this raster. So that's why we need to keep this track. Cool. Also, I need to keep track about the program state itself. So what is where, right? I need to really understand what is the location of the information in the memory. And what is cool is like the debuggers provide everything for you. Okay? Saying that, hey, I just need to keep track of that, but it sounds like easy, and in the end it is, because all the debuggers provide it to you. That's why the debuggers really exist, to provide this information. And well, there is a special case for the heap memory. Because the heap memory, due to the heap memory protections and the way the vulnerabilities in heap overflows nowadays behave, you really need a special attention for the heap. Because it's not just because you overwrote a control memory related to the heap that you have control over the system. Because sometimes this chunk of memory are not going to be freed or are not going to be copied to somewhere that you can really achieve code execution. So to keep track of the heap memory, you need to keep track of all the calls that manipulates the memory. So, like, for example, if you have a Linux system, you are going to keep track of the malloc and free. You are going to keep track of everything that is really using the heap of the system. There is plenty of different ways, and there is another challenge, which means that big applications have its own heap implementations. So I don't know if you guys ever had a look into the, I don't know, Samba code, Keymail code, Word, not code, right? But Word or vulnerabilities or whatever. But all the big applications have its own allocators. Why? Performance reasons. So you need to keep track and better understand these allocators itself. So usually, how do you do that? Basically, you need to have a past vulnerability on the system. You test the exploitability. You understand how the allocator works, and then you start to update the information of the heap hooks. So, if a instructional write into the memory address, then we know this memory address is being used by the application itself. We have a write. If it's being read, we know there is some information that needs to be in a readable area. Why this kind of information is important? Because, for example, the G8 client vulnerability in Linux, it was a Stack Overflow vulnerability, but for you to exploit it, you need to control, you are overwriting two specific pointers that you need to point to valid memory areas because the function is reading these areas before really returning. So you never get control over execution if these pointers don't point to a real memory area. How do you know that? Well, you can debug each vulnerability and every time do the manual stuff, or you can just keep track and launch the exploit and see, hey, there is 2 memory areas that I need to have a read access. Every time there is a write, if this write is happening in a memory area that I control, it's in my control list, I know there is a memory corruption. That's the easiest way. So I can just feed back the fuzzer and say, hey, there is a memory corruption. But sometimes it's going to happen that the memory area that you are writing to are just another memory area in the used list. So that's why the problem is always growing, okay? That's why I'm not saying this is the how can I say, the supreme solution. It's just part of the process of getting into the solution. So, again, we don't want to do, okay, single stepping, okay? If you do single stepping while fuzzing, you are going to kill yourself because you are not going to find anything in time anyway, okay? We want to have the performance gain. So what we do is like every time that we really need to stop the application to look into how the application is behaving, then we do static analysis to see what's going on in the future. That's why the mutation is so important. Because then we can see, hey, there will be a jump condition. There will be something here that I need to avoid because I want the actual code to continue. We don't want, to break the application and do single stepping or whatever. So, specifically talking about the heap information, you can easily create a heap view. So, many vendors, I don't know if you guys ever looked into the security appliances, but I'm sure there's one guy here who already looked into security appliances. But if you start to fuzz the security appliances, you are going to see a lot of, weird behavior when you really have something being overflowed. Why? Because most of the security vendors, they kind of keep track of the unallocated space in the memory. So let's suppose you are a security vendor, you are like, for example, a firewall company, and you have a really huge project, okay? You are handling a lot of packets. You don't want, to forget to free some pointers because this memory you are not freeing are going, to consume your machine, and in the long run, your machine are going to stop to work. So these vendors also have heap implementations, and they have a kind of heap view. How can you easily write a heap view? The same way that the guys are keeping the heap protection, basically what they do is, every time there is a written to the block list, you can check the canary of the heap, right? they don't create a real canary in the heap, because it's going to be really time-consuming to really verify that every time you are freeing. So instead of do that, they just verify if the pointers are really pointing to valid addresses. But what you can do is you can just insert this canary. So if the canary is being overwritten, then you need to look into it. And well, there is other projects that are already providing, like HeapView, like Core Security released a plugin for Windows Debugger or for IDA, I don't remember exactly, that exactly provides you this HeapView. So you can easily get what they did and just, modify for what you need. Yeah, good coders copy, right? So also, you want to have this visual of what's going on with the heap, so you can detect these main leaks or other kind of problems that usually don't go to the corruption immediately. So, as I said, I mutate the target so I can solve the deterministic problem, but what if I am auditing like something running in the kernel? Can I mutate the targets also running the kernel? Yes, it is possible. The Rasta debugger is an example of a debugger running in kernel mode just using patches and hooks inside the kernel. So yes, it is possible even if you are debugging like in kernel mode, not necessarily in user mode. Some of the algorithms that are being used in this approach are machine learning algorithms for the evolutionary fuzzing and SAT solvers and stuff like that. And of course, we need to create a model and keep tracking of all the call dependencies. That's why WinDebugger, IDA are really great, because they help you to do that. You don't really need to code everything. You can just, use what they already provide for you. Another problem that you can solve is like conditions that don't exist in the full installation of the software or in the full configuration or in the deployed configuration you are testing. So let's suppose you have a vulnerability, but this vulnerability just happens if some specific feature of the software is enabled. You easily are going to spot that because you are going to see there is a condition in the software that you don't have control over. So why you don't have a control over this condition? Maybe because this condition is coming from, for example, a file, a configuration file. So you can easily keep track of the configuration files being read by the software, and then you can discover vulnerabilities even in different configurations than the one that you deployed. This is especially useful when you are auditing like server software. Let's suppose you want to audit Apache. How many options Apache have? How many different configuration options do you have for Apache? How do you really fuzz Apache? It's pretty crazy, huh? It's a really big software with thousands of options and configuration options. And well, it's also important to have the mutation of the target because of a specific challenge that I faced while I was auditing a POP3 server. So POP3 servers are especially interesting because usually you don't interact, you don't send an email to the POP3 server, right? You send the email to the SMTP server, who kindly will parse it and will save it in your maildir or mailbox, right? And then the POP3 server, when the user logs into the POP3 server and asks for this email, the POP3 server will get the email and will show to the user or whatever, right? The POP3 server needs to parse and needs to deal with a lot of stuff. So if you look into the GNU POP3 server, for example, it will create a cache above the information it's reading. Why? Because when you have like a maildir infrastructure, you know that you have thousands of different directors for each email because it's performance-wise, right? But to really parse all the directors and find where is the emails of the user, it's a complex piece of software. So what they do, they create a caching mechanism that will always keep tracking of the latest read emails. You don't really have control over this cache. Who is really writing to the cache file? It's not you as the attacker. So how do you force a fuzzer to write to the cache file? It's a pretty difficult task, right? You are sending an email. Let's suppose you are using Keymail as the SMTP. Keymail can parse the file and can remove something that you already sent. You don't know. You'll never know if the email server is going to parse it or not. Keymail is going to save the file in the maildir directory. The POP3 server will read the file, and the POP3 server will save the file in the cache directory, in the cache file. What is interesting is, like usually, because of this security-wise, the POP3 server will drop the privileges, and when it will really write the file, it's writing the file as your user, right? It always tries to write the file as your user. So which means that the user, if they have like local access to the machine, the user can create the file straightforward. So you can, the user can interact with the parser of the caching files directly without passing to the writing and to the reading. But a fuzzer, how do you do that? To really automate that with a fuzzer or to really spot it's happening? In this case, how do I spot it? Well, I read the code. It's a pretty straightforward way to do that in open source software, but how do you really do that in closed source software? How do you spot what the software is reading? The only way is if you keep track of how the information is being used and what is optional and why you are never controlling some specific kind of information. So, cool. Why Valgrind? Well, Valgrind is a suite of tools. It's pretty cool. It has a lot of stuff. Everybody uses Valgrind for profiling. Everybody uses Valgrind to detect main leaks and stuff. And, well, it supports extensions, the plugins. And, well, it provides you the intermediate language, which is VAX, which is a RISC-based language. So it's cool. It provides everything that I needed. The only problem is it's not so portable as I wanted. So I created a ported version for Windows, which is not pretty as I wanted, but yes, it works. It works with WinDebugger. So as I said, there is the need for the intermediate language, but I've not been really clear why this is really needed. Well, you need the intermediate language because the assembly language is a pretty fun language. That's why everybody loves it. So how it works? Let's suppose I have a push EAX. So, well, it's a simple operation, right? I'm just saving a value into the top of the stack. But the push EAX has the EAX as, explicit operator, but there is some operands that are implicit here. Basically, you are decreasing the stack pointer, you are using the stack pointer to point to a location and to save the value of EAX into that location in the memory. So the assembly language, it's pretty fun, it's pretty easy, simple, but you have a lot of implicit stuff going on. So some hashes are being modified and some stuff are going on and you don't see it. The intermediate language are going to provide this kind of information for you. So Valgrind, I will talk specifically about how the Valgrind plugins work, but I will be really fast because it's not, the most important stuff. What is important is to understand that all the debugger tools are providing the same kind of infrastructure for you, so you can create plugins for IDA or plugins for WinDebugger or whatever you want. In fact, I will show the result of the WinDebugger output, not the Valgrind one. So basically, the Valgrind, you can have your initialization function that will do whatever you want, and in my case, it will set the handlers, and it provides you the handler for whatever you want. Actually, the debuggers are pretty cool in that. So, for example, you just want to see when a memory is going to be written, when it was just written, when there is a system call, when somebody's changing like a protection of a memory area, when somebody's remapping, mapping, calling BRK straightforward, or just using the malloc implementations. So Valgrind provides everything you need, and all the debuggers are going to provide you the same. Also, you can easily instrument. So the idea of the instrumentation with Valgrind is exactly the code that I just showed executing, that you can look into a jump, for example. You have the VAX instruction, which is related to a jump. You know it's going to jump based on a condition. You can just say, okay, change this jump to an unconditional jump, for example. And it will do that for you. You don't really need to care about size of instructions or whatever challenges you have, okay? As much as you are working with a RISC machine, exactly the same way. Okay, so why don't do that? Like, for example, the Heap view just using like a preloading of libraries. There's some tools that using preloading. Well, first of all, when you are using preload to keep track of the call, malloc, realloc, or whatever allocation functions you want to keep track, you are missing the inlined functions. Sometimes there is inlined functions. Sometimes there is straightforward calls to the system call. So as I said, a lot of big projects are calling the BRK straightforward or are calling underlying operating system straightforward, and they don't count on the heap management of the operating system. So it's a problem. Also, the other problem is you are breaking the Heidelberg principle, which says that the debugger cannot change the behavior, the internal behavior of the application. Which means when you have like preloading of libraries, you are changing the loading addresses of all the libraries. Okay, so you don't want to have it. So the debugger is the best option. As I said, the biggest challenge is how to get this problem that's undeterministic problem and solve it in such a way that we can really create an undeterministic machine to solve an undeterministic problem. So how do we do that? Basically, the idea is like instead of have like the address of the instruction that you are changing or the instruction you are testing and the offset. So what we do is we have like a node address as well. So basically, the basic idea is like we can really clusterize the problem. We can create a lot of machines, running virtual machines, running words, and each of these machines are opening the Office file, and each of these machines are part of the cluster, and I know what one machine tested, so I don't need to test it again. Okay? The other machines are really going to do the work. Since I'm just modifying the information on the targets and not on the fuzzer, on the origin itself, it's much easier to distribute the problem. I don't need like 3 machines generating traffic and 10 machines receiving. I can just have the machines with the target application running. I don't need to say that there's thousands of problems in the synchronization and stuff, right? Cool. As I said, there is set solvers, other like decision algorithms being used, meta-heuristic search algorithms, a lot of stuff, and the output is not pretty. So just to have an idea, the idea of the output is something like this. So as you can see, it's not exactly a text file. It is supposed to be loaded in an interface, but I had no time to finish the interface in time to present here. But what is the idea of the output? So this is specifically the same word vulnerability if you look into the faulty instruction itself. Let me see if I have it here. Yes. No, I don't. Yes. So I don't have the faulty instruction, but you easily will see this is the faulty instruction because, whoops. There we go. Whoops. Yes, here we go. So we have a move word PTR. Yes. Okay. So as you guys saw, what the debugger was showing is like there was a heap interruption, and in the middle of the heap allocation routine, the program just stopped to work, right? That's what the debugger was showing. So just to see again, the debugger is showing, okay, there's a breaking point for some reason. That's calling a break instruction. If you look into the debugger, into the stack information, you are going to see, hey, there's really a debug breaking point. It was in the middle of some routine, allocation routine, and well, you can see it came from an MS-HTML library, but well, what really happened? It's pretty difficult to really understand, right? How do I backtrack it? How do I go back and say, hey, what really happened to the code? So basically, the information that I have here is much clearer. Of course, it's not that much clear, right? But well, for me, it's pretty clear to see that, okay, I am moving a value to a specific position in the memory, and well, it kinds of pointing to invalid, right? So then I need to determine if this invalid pointer is something that I control. The DI is something that I control, okay? I'm receiving the information. How do I know, okay, this is where it's pointing? I know I control something that's being written to some place, but I really don't know if I control where it's being written. That's what I need to determine. If I have control to where it's being written, I have like a overflow, okay? I control something, I can write some address. It's partially because, as you guys can see, it's DI, not EDI. So I partially control an address, right? It's not a double word. If it was a double word overflow, for sure it's a code execution. It's pretty easy. Wow, cool. But that's not the case, okay? It's just a word overflow. So literally, in Word, a word overflow in Word. I promise it was not on purpose. So it's really cool as well, because look into what the tent analysis is telling me. Hey, there is some kind of routine changing the behavior of your input. Wow, that's pretty cool. There is a tool-hour. So I know if I want to really exploit this vulnerability, I will need to bypass this tool-hour call. So if you look into the size of the word, and if you look into the size of the information that the tent analysis really gave to you, you are going to agree with me, it's much less, but it's still a plenty of information that you need to deal with, okay? So, of course, it's much less than Word. It's giving a lot of, really nice information. What's missing now is a graphical tool that will help to really exercise that. And, okay, cool. Since we know that, what else we have? So, let's do a case study, right? Let's get some vulnerability. That's what everybody wants, right? Okay, so basically I will do 2 case studies in the slide, and 1 case study I will just show the exploit working because it's more fun, right? Cool. So the case study in the slides are published vulnerabilities, but you are going to understand why it's important. Okay, so Solaris is a cool operating system. I like Solaris pretty much, so I decided that Solaris was cool to looking for vulnerabilities. And okay, so sadmin is like a daemon used by blah, 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 blah to control the Solaris operating system. I don't really need to know why the software is used for. I just need to know the software is there by default. So basically, me and some Brazilian guys, we have this Rise security group. We usually publish some cool stuff. If you guys use Metasploit, for sure you use stuff that we did. And well, basically, in October of 2008, we released like 1 vulnerability. Pretty cool, working exploit, straightforward for the Metasploit, because there's one of the guys in the group who is actually a Metasploit developer. So he ported the shitty exploit to be a nice Metasploit one. Really beautiful, it worked pretty well. And well, what is funny, like, sometime later, I will show you the timelines, Secunia released 2 other vulnerabilities. What the heck? Hey, come on, it's in the same software that we audited, and they found two vulnerabilities that we didn't. I was really pissed with that. But, well, there was no details at all, which is funny, right? Why release a vulnerability if you don't give details? I don't like it, but, well, that's the behavior of the corporations, right? So, okay, it's pretty cool. Like, the temporal score was 7.4, remote heap overflow, one of the vulnerabilities, okay? Well, why it's 7.4? Because it's unproven the exploitability level, which means Secunia didn't wrote an exploit, right? That's cool. They release a vulnerability, but they don't know if it can be exploited. Also, there's another one which was a remote integer overflow, and again, the exploitability level was unproven, and well, it's funny, they say that the complexity of the vulnerability were really high. Oh, really? That's funny. So what I hate in these advisories is exactly that. They don't provide any details, right? So how do you find the vulnerabilities? And in the beginning, I said, hey, come on, do you think that the Secunia released the same vulnerability as we did? I don't know, I don't think so, right? So we didn't pack that. Secunia is pretty cool. And one of the vulnerabilities wasn't exactly the same function. That pissed me much more, right? Because every vulnerability you find is money in your account, right? Because you can sell the vulnerability, people pay, iDefense pay, Tipping Point pay, Cosink pay, a lot of companies pay, and they do good stuff with the vulnerability, so I don't like to, not see a vulnerability in the same function. Fuck. So I decided to do like some kind of tent analysis in the function again to verify if I can spot the vulnerability now that I have something better. So basically we see there is a call to a specific function, and it's using a value that we control. So I will call that a tented value, okay? How I know it's using? Because, well, there is a push of this value, okay? So I know in this call they are using. Okay, inside this function there is another, push of value from another value that I control, so I'm propagating the tent. So I control the first value for the call. This value was used in another information in the area of the memory, so I still know I control it. And then there is another call to another routine. This routine is using the tented value as a parameter for the next call. What is the next call? Oh, that's pretty interesting. It's an allocation function. So let me try to understand it right. I control the size of the allocation. That is pretty cool, eh? So how do I control this size? It's a header information. But what if in the header I send, like the size is 10, and in the data itself I send 100? Wow, pretty cool. It's going to copy 100 bytes inside a 10 byte size buffer. Wow, pretty smart, huh? Pretty smart. Right? So basically they are calling a function, they are reading the data section of the package, and they are reading until achieve null. So they are reading and copying a buffer, but the allocation of the buffer comes from the header of the package. Don't seem like pretty smart. So pretty funny, pretty easy to exploit heap overflow. So let's go to the complex one, right? If the first one was so simple, let's see the complex one. So, well, basically they are comparing some values, they are allocating, there's allocation routing again. So I said, oh, come on. Do you think it's going to be a allocation problem again? Maybe. So there's a reallocation, they get the current size, they get again the size from the header. Okay, so we counter the size from the header, so we are tainting it. They get the block size also from the header, so they get two sizes from the header. And oh, that's really beautiful. They multiply two sizes that we control. That's really beautiful, eh? They look into the sizes, they know if the sizes are going to be big or not, but in the way they are using the size, it's exactly a multiplication. So if I provide like two large sizes, it's becoming like a pretty small size. So, again, pretty easy to spot and to really exploit. So, not happy with that, I decided to have a look again into Solaris, and I found this vulnerability that I expected to be published already, but it's still not. But you guys are sure going to see this vulnerability in the next month being released. Basically, this vulnerability affects Solaris, HPX, and AIX, which is pretty cool. So it means it's not in the SA admin. It's not in SA admin because SA admin it's not being used in Solaris, AIX, and blah, blah, blah. But what is really cool about this vulnerability, well, here's the exploit already executed, okay? Just in case if it fails, here's the exploit already executed. I will just do an ls, okay? Just in case. But okay, I will stop the exploit. I will ping the Solaris machine. Wow, it's pinging. So I have the Solaris machine running here. And so I will just execute the exploit. And, well, I replaced the name with XYZ, but yes. Oh, cool. Remote root sun again. Wow, nice. ID, root. If I do a cat, etc, shadow, it's pretty cool. If you guys want to discover my password, just get it and brute force it. It's really cool. You are going to discover it's VMware. Okay, so the vulnerability is not important, okay? I just show it because it's cool to see, hey, how does it works in the end? It's really easy as it sounds it is. Not really. As you I showed like a really big file with a lot of assembly code exactly to say it's not really easy, but it is really fun, that's for sure. And, well, we have much more motivation, as I said in the beginning, because as more as they fix, as more time I will spend in finding it. So it's pretty cool. Some related projects, just in case if you guys really want to understand more and really want to like deal more with this kind of information. There is also a presentation by Cousin Inc., by Ben Nagy of Cousin Inc. Oh. Wow. That's a projector attack. Okay, cool. There is also a presentation by Ben Nagy from Cousin Inc. about this word vulnerability that I told you that Cousin Inc. Have the property over. This one that I showed is a different one. It's not related to this 200,000. So believe me, everybody can still find vulnerabilities in words and stuff. So the message is I can't foresee the future. I know everything is improving, but I don't know how it's going to end. I'm developing a lot of stuff related to that. I'm really happy to contribute and to exchange information with other researchers. Even more because every time you are going to audit a different system, it's a different challenge, a different allocation routine, a different way of the system works. So it's pretty cool if you guys work with exploitation. It's really cool to keep in touch. And as I said, the focus of this research in the debugger itself. So that was my message. I am here for questions. And also, if anybody wants to pay me a beer, I will accept this.
Anyway, even without Mike, thank you very much for that
it's my pleasure.
Talk, like always.
Thank you.
So, do we have any questions?
Yes, please.
correctly, what you do is you use dynamic change analysis to modify. Will it be possible to do data flow tracking before doing the fuzzing and construct your fuzzer in a way that it uses the result from data flow tracking?
Yes. This is actually really possible. This is not something that I am doing because, well, first of all, I'm not sure exactly which kind of paths I really want to see, right? When you are constructing a fuzzer for the first time, basically what you have is like the specifications of the format. Not always the format is open. Like this Word project started before the format was open. When the format was open, then it was much easier. But there is a lot of closed formats that you don't really understand how you can create files to really achieve what you want. So we want something that will mutate and will grow accordingly. Also, I really don't want to create something that will too much dependent. I want, to make it the debugger side as easy as possible, like growing as the software grows and understanding how the application works without have a dependence of the application itself. But if you look in the output of the tool, in the end, it's basically giving you the hit traces. So you know what your code passed through and what is changing your code. So in the end, you have this information, but I don't create the information previously. I give you later.
How can you make sure that the vulnerable control path is hit by the fuzzer? I mean, if you run an FLC, then sooner or later it gets hit.
Yes. One of the smartest things to assume when you are fuzzing is like fuzzer is not something to the guy, to give to a dumb guy, just press the button. Okay, so not saying that Codenomicon or this kind of fuzzers are not going to find stuff. They are pretty basic, but they are not going to find the kind of stuff that I am interested on, which is the complex vulnerability. So basically what I assume is like the guy who is going to use it's an analyst who have experience and who knows what he wants to test. So for example, in this Solaris vulnerability I just showed, I knew what is the functions that I want to test. I knew where is the problem, because the problem is usually in the parsing functions, in the functions that deals with network, in the functions that deals with the file. So I know this is the range of information that I really want to understand, and these are the information that I am taking care of now. Of course, if you have the research to really leave the cluster running, like Cosa Inc. is running this stuff in 16 machines with hundreds of virtual machines, okay? So of course, you can just leave it running. But what I'm developing for is like to get a specialized guy who will really point into the places where there is the vulnerability. The idea here is also that you can easily create an exploit code as soon as somebody releases a patch. So my idea is like, okay, you get the patch, you binge the patch with the original binary, you get where is the vulnerability, you put this information on the tent analysis, and boom, it will show you how to create the file so you can exploit it. The idea is like exploiting creation really fast for well-known vulnerabilities. So every time Secure release something without giving details, we can release something with all the details. Every time Fortinet go and release something without details, we go and release the public exploit. So we are going to remove this, business behind the security.
Okay, due to the overtime, I would say for further questions, contact Rodrigo directly. I'm pretty sure you will be around for the rest of the day,
Yes.
right? Okay,
Tomorrow.
so then enjoy the coffee break, and we're going to continue in about 20 minutes, I guess.